So let's start off with a pop quiz today. What do the stock market, the shampoo you used this morning, your favorite Pixar movie, and the medicine that you or your loved ones need have in common? The answer, as you may have guessed from the introduction, is high-performance computing. High-performance computing is ubiquitous in our world. It exists in many places that we don't even know about. So, for instance, the stock market has lots of institutions associated with it that are always trying to predict whether the market's going to go up or down. And they use HPC to model these factors. The medicine in universities or in drug companies also use these types of models. The shampoo bottles, companies like Procter & Gamble will actually model down with accuracy to millionths of an inch the amount of plastic that's being used, so they can use it for storage or for saving costs and things like that. And Pixar is actually an HPC company. Many people may not know that they actually produce software called RenderMan that they use to render all of the pictures that the artists are drawing. And they'll take those and combine them together and push them together through an HPC system. But when you think about supercomputing, what do you think of? Probably a lot of you think of big rooms, noisy, loud, maybe people using punch cards or coding in Fortran. And yeah, those kind of things do exist. Maybe you're remembering last year when Watson was on Jeopardy and really trounced the other two contestants. Again, that was an HPC system. Or maybe a few of you are thinking about HAL from the movie 2001 or Skynet from Terminator. Yeah, that's an HPC system as well. But I'm here to tell you that supercomputers really aren't that scary. So this is a system designed by IBM. It's called Blue Gene. And these are the types of computers that about 15 years ago were the first to beat a human at chess. But this is also an HPC system. This is actually one that's in my office. It's just 4 computers that are networked together with a certain configuration. It's got some special software in it. Not quite so intimidating, is it? Well, who uses supercomputers? Well, for the most part, we think of Linux-type people who sit in front of a command line screen all day long. And for the majority of HPC systems, that is who the user is. Really deep knowledge of computer science, plus maybe some sort of specialized field like biomedicine. For a long time, HPC has been in the hands of these elite types of users. But Microsoft actually supplies an HPC cluster manager as well for people who administer these large supercomputing systems. And we've had this for about 6 years now. And so this actually allows an administrator to see what's going on at a glance in any of these big types of systems. But there are actually other types of users using HPC that you might not be thinking about. So let's meet one of these guys. This is Mike. And Mike is an actuary that works at an insurance company in San Diego. Mike is really good at math. He's really good at economics. He's taken a computer science class because his advisor told him it would help him out in his career, but he doesn't really use it that much. And the reason that he doesn't use it is because he spends all of his day in Excel. When you and I use Excel, most of the time we're using it for pretty simple calculations. Arithmetic, maybe some algebraic formulas, things that calculate pretty quickly, almost instantly. Or if we're more advanced, some of us might be using Power Pivot to do some things that take a few minutes to calculate. Well, when Mike is using Excel, he has models that hold hundreds of thousands or even millions of cells that are containing all this data that he needs to know for predicting what types of risks are associated with certain types of disasters. So when Mike clicks that Run Model button, it's actually going to take 8 hours for his model to calculate. So when we've talked with Mike, what we find out is that he'll actually run this at the end of the day before he's getting ready to go home because it takes up so much computing power. He can't do anything else on the system. So he runs it overnight. He comes in the next day. Hopefully, he's got his results. Hopefully, Excel didn't crash, or he finds out that he input something wrong into his model and he's got worthless data. So you can imagine that he gets to do this at most once per day. But actually, in Excel, there's an option that allows you to run on a compute cluster. If you look in Excel 2010 or 2012, you actually see this in the advanced options right now. So what does run on a compute cluster mean? Well, if you've got the right hardware, basically for running a server, and the HPC pack cluster that you can get from Microsoft, you can actually hook it up to what we call an HPC cluster. So there's really two basic things you need to know about an HPC system in a very, really oversimplified way. One is that it contains a head node and compute nodes. So a head node is essentially just a computer that's been told it's the boss of all of these other machines that are in this system. And the user will interact with the head node. So it'll say, I've got this job I want to run, like Mike's model, and this is all the data that's associated with it. Well, what the head node then does is talks to all of these compute nodes that are associated with it. And if you're in a traditional enterprise type of place, then these are probably going to be on-premise somewhere. You can actually physically go look at the machines. But someone like Mike, who's working at an insurance company, probably doesn't have that type of infrastructure behind him. So he'd want to use the cloud to do that exact same type of work, which he can now do. So what the head node is going to do then, whether it's on-premise or in the cloud, is take that job and divide it up into hundreds or thousands of pieces and give those to each of those compute nodes at the same time. So they're all running those jobs at once. We call that running in parallel. When they're done, they send that back to the head node, and the head node says, okay, Mike, your job is done. Here's the result. And that's really all an HPC system is in a nutshell. So that same model that Mike was running, if he hooks up to an HPC system, depending on the amount of resources that he wants to use, that same model can now take 5 minutes to run. So you can imagine how much more efficient this makes him at his job. He can run lots of models during the day, refine them a lot more, just to make sure that he's doing his job in a much better way. And in the HPC team, this is what we call democratizing HPC. We're actually trying to bring it to a place where it's no longer those elite Linux users that can only use HPC. It's anybody, any type of information worker could be using it. So even in UX, if you're running a large-scale survey, or maybe you're analyzing Twitter feeds or something like that, you could be using an HPC system to do that analysis. Or if you're a designer, you could be modeling 3D things that you're creating, or you might want to visualize data in real time. You could be using an HPC system to do that. In the future, we're going to see a lot more people doing this type of thing. And this is one of the things that we as the UX team for HPC, love seeing, because we get to meet all kinds of people doing interesting jobs and really changing the world. Thank you.
All right. Thank you, Ryan.